Let's take a quick peek into NCache architecture. Please note that NCache is industry's only 100% native .NET caching solution. If you have a .NET application, NCache fits into your application stack very nicely. Here's how NCache is typically deployed in the enterprise to achieve extreme performance. Please note the separate caching tier with 2 or more cache servers. NCache allows you to add more servers at runtime without stopping the cache or your application. Please also note that you don't have to have a separate caching tier. Your application and NCache can run on the same servers. Your applications that use NCache are usually web applications, microservices, web APIs, or other server applications. Let's dive into the NCache architecture. The heart of that is its dynamic architecture. The first part of that is dynamic cluster. NCache has a TCP-based cache cluster that is peer-to-peer in nature, which means there's no master or slave. This dynamic cluster means that you can add or remove servers at runtime without stopping the cache, and the cluster membership information is propagated at runtime. This cluster also has a connection failover feature, so if the connection between the servers break, they automatically reconnect to each other. The second part of the dynamic architecture are the dynamic clients. You can add or remove clients at runtime without stopping the cache or your application. And all the configuration information, which is cluster membership, caching topology, distribution map, is propagated to the clients at runtime. And even if it changes, it gets propagated at runtime. The clients also have a connection failover feature. So if their connection with the cluster breaks, the clients also automatically reconnect with the cluster. The third part of the dynamic architecture is the split brain recovery of the cluster. Just like any distributed system, NCache cluster can also see split brain because of network issues. When that happens, NCache detects the split brain and automatically recovers from it when the network issues are restored. Caching topologies are strategies on storing and replicating data in the cache and how the client should connect to different servers. The first topology is called mirrored cache. It's a 2-node active passive topology. All the clients connect to the active node that has an entire copy of the cache, and another copy is kept on the passive node. All the changes from active node are asynchronously backed up to the passive node. If the active node ever goes down, the passive node automatically becomes active and the clients connect to it. The second topology is called replicated cache, in which every server in the cluster is active and it has an entire copy of the cache. The clients usually connect to only one server, but if that server goes down, they connect to any other server in the cluster. All the reads are super fast because they're local to that server, but the updates have to be synchronous across the cluster. Another topology is called partition cache. This topology provides you linear scalability because the entire cache is broken up into partitions and every server has one partition. And the clients connect to all the partitions so they can directly access, read and write data from that partition. There's a dynamic data balancing feature that ensures that all the partitions have pretty much the same amount of data. Another topology is called partition replica cache. This is similar to partition cache, except every partition has a replica on a different server. And this replica provides high availability. So if any one partition goes down, there's no loss of data. Partition replica is our most popular topology because it gives you best of both worlds. It gives you linear scalability from partitioning and high availability from replication. The replication is asynchronous by default, but you can use synchronous replication. And this also has dynamic data balancing. Client cache is also a very powerful feature that gives you in-proc speed. Client cache sits on your client or your application server, even within your application process. And whatever your application fetches from the clustered cache, it's kept in the client cache. And if that data changes in the clustered cache notifies the client caches to update themselves. So it's kept synchronized. NCache provides WAN replication feature across multiple regions or multiple zones. If you have, for example, a 2-site deployment of NCache, it could be either active-active or active-passive. You can do WAN replication across that. If you have a 3 or more site deployment, then one site has to be active and the others can be a combination of active or passive. Please contact us to schedule a demo about an in-depth NCache architecture, NCache features, and strategies on how you should use NCache in your application. Thank you.